All right, we are going to look at waves today. We're going to just introduce what the waves are we are going to be looking at in this chapter. So remember, the main purpose, what a wave does, is it transfers energy from one place to another. It doesn't transfer matter, it doesn't transfer anything like that, it transfers energy. Okay? So there's two basic types. There's mechanical waves. This is where there has to be things that have to move to transfer that energy. Electromagnetic, this is a wave we're going to talk about when we talk about light. So that is going to be a little bit later on, and that's where we store our energy in electric and magnetic fields. So the mechanical wave stores that energy in the form of typically a bond. A chemical bond you can think about stretching, or just a spring stretching, or air pushing up and then having a difference in pressure. So some form or another, it stores that energy. So there's two types once we start talking about mechanical waves. There's transverse waves that have a disturbance perpendicular to the direction the wave is moving. And then there's longitudinal waves that have a disturbance that is parallel to the direction of motion. And so let's go take a look at what those waves look like. So we're going to look at how a wave travels on this slinky. So as I make a disruption, and this is going to be a transverse wave, so I'm going to make my disruption so it's perpendicular to the direction of motion. That wave travels down and reflects back. And it reflects back and forth, but it does lose some energy each time. If I send a longitudinal wave, so that's where my disturbance is parallel to the direction of motion, it looks like this, and it does something similar. Okay? But what I want... All right, now that we saw what those waves look like, let's go ahead and identify some parts of them. So we have a crest, and that is the point where we would say it is at the top, and a trough at the bottom. And we call this the wavelength from one crest to the next, or from trough to trough, or from maybe this point to this point. The amplitude is how far that has been stretched from its standard point, its equilibrium position. Okay? So if you see a wave out in the ocean, in order to get the amplitude, you might have to measure from the trough to the crest and then divide it in two. Okay? Longitudinal waves, on the other hand, these are those waves that where that disturbance is parallel to the motion. Sound is a great example of this, where we have areas of high pressure, areas of low pressure, and as they move, your ear hears those changes in pressure, and that's what it translates into sound. So we have these high pressure areas called compressions. We have these low pressure areas called rarefactions. Okay? And so what we do with these longitudinal waves is we'll typically graph their density. Where's the pressure the highest? Where's the density the highest? And the lowest. And so what this would look like is here I have a high density, and then it goes to a very low density. And then it comes back to high, then back to low, then back to high. And so we end up with this wave pattern. Okay? And this, again, is our midpoint. This is what the pressure would be if that sound wave was not transmitted through it. And so the wave goes from high to low pressure. And so this is where we can get maybe something that looks a little more like a wavelength and a little more like an amplitude from when we graph that density. There are some equations we can use for dealing with waves. So one of them is that the speed of that wave is equal to the frequency and the wavelength. So you can look at the frequency of it, you can look at the wavelength of it, and from those you can figure out how fast it's moving. So if you were on a ship sitting in the ocean, you could say, okay, how far apart are those wave crests? All right, I can get the wavelength. And how often am I reaching that maximum height as those waves pass under me, and we can then, from that information, figure out how fast that wave is moving. Now, frequency, that's also 1 over the period. So if I timed how often it was from one to the next, I would just have to take 1 over that time to find that frequency to figure out how fast I'm going up and down. There you go.